Okay, good morning, Stephan. Good morning, Stephan. Nice to meet
Morning.
you. Thanks for joining us and doing this presentation about track and traceability, your solution. And I would say thank you on behalf of the Bundesblock and behalf of our members. And yeah, just fire away. I think the question and answers will be, what's your intake on that? While the presentation or afterwards?
Preferable afterwards.
Okay.
I have
Let's do so.
the last slide is a questions, so happy to discuss a lot of things then. Otherwise,
Wonderful.
we have a risk that it will take 2 hours, so 2.5 hours or something like that.
No problem with me.
I'm happy to discuss afterwards. So yeah.
Very good. We have also the chat comment section. So if you're interested in doing some typing, just fire away also. Okay, Stephan, go ahead.
All right. Thank you very much for inviting me to this. So my name is Stephan Nilsson. I'm originally from Sweden. I'm now based in Norway since 9 years. I'm the CEO and co-founder. So maybe let me show my slides directly because I have it also in there. Yeah. So I'm going to talk about our platform called UNISOT. UNISOT is what we call a real-world asset traceability platform for global supply chains. So we are specializing in supply chains because that's my background. Our vision is to provide global interoperability to all supply chain actors out there and to enabling them to be more sustainable and to empowering greater transparency through the whole supply chain. And that is the biggest problems that we have today, impacting global economy, impacting sustainability and health and on all of that. So we need much more transparency in global supply chains today. The first things we're focusing on is food and beverage, because in our mind, that's the most important thing for humans to survive. We need food. After food, you need shelter, and you know the whole triangle. And then we are expanding out to other industries, but we started in the food and beverage industry. I'm gonna explain that we are also in other industries now. We have customers in other industries. I will talk more about that later on. A little bit about me then. So I'm Stephan Nilsson, the CEO and co-founder of the company called UNISOT. The name UNISOT comes from, it's a short for Universal Source of Truth. So the idea from the beginning was to create this universal source of truth for every company in a global supply chain by using the public blockchain. My experience before I started doing this back in 2019. In 2019, I quit my job at Ernst & Young. And before that, I worked 20 years as an SAP integration architect. So the German SAP ERP system. I was traveling the world around helping companies that have SAP systems, and I was helping them integrating their SAP system with their other partners in the supply chains, to the suppliers, to their customers, to the banks, to other IT systems, warehouse management systems, and so on, building these interfaces, a lot of EDI and EDIFACTs, also custom build interfaces and so on, to exchange information like orders, invoices, bill of ladings, and things like that. Even before that, I totally have more than 30 years experience with system integrations. My first job was actually working at Tetra Pak, the packaging company from Sweden, doing the milk and juice packages that you find in the shops. I started integrating them actually, integrating their filling machines, connecting the cables, programming the communication program in their old PLC, programmable logical unit at the time, starting in something called Allen Bradley systems, and then it the Tetra Pak developed their own systems, and so I program in there in a logic programming language, serialized information, put it out on a cable, put a cable to a central computer, and then we did with ASCII graphics, a kind of graphic screen with all the filling machines and the status of every filling machine. So how many packages they were making and how many alarms there were and so on. So kind of a production management system. But this was back in like the 80s, 90s, early 90s. So very basic things, but that's where my communication career started, integrating filling machines, and then go up to SAP and these kind of things later on. So I mentioned I moved to Norway. So in 2014, I moved to Norway, and at the time, when I was interviewing for this new job, I was talking a lot about what I wanted to do with SAP and blockchain. And they said, block what? Blockchain what? They had no idea what blockchain was. But for some reason, I got a job. So I took my family and moved from Belgium at the time, and moved over here and started working. And starting on my free time between assignments as an SAP integration architect in the weekends and holidays and so on, I started to integrate SAP with the blockchain. So I started building a vending machine home in my garage here. So a wooden box with a small touch computer, a Raspberry Pi touch computer, some servers and so on, where I could pay with Bitcoin to this vending machine. And I got a box of sweet out. But the interesting thing was that I also had built a module in SAP. So when I paid to this machine, got my box of sweet out, SAP created a sales order. And SAP also kept track of the magazine level in that machine. So when the magazine level went too low, SAP created a replenishment order. So by doing that, I proved to myself that I can actually integrate this very centralized SAP system with this very decentralized blockchain system. So that was the whole start for the company UNISOT. I worked on that on my free time and holidays and between assignments for a couple of years. And then in 2019, I realized, yeah, I have a solution. I want to work with this. I got some funding. So that's when I quit my job and went head into this startup community and with the company UNISOT. When I moved to Norway as well, I was looking from blockchain community there, couldn't find anyone. So that's when I founded the Norway Blockchain Association. Had a lot of things to do there until a couple of years ago. And unfortunately, I don't have that much time anymore to run it since I'm running the company. So it's a little bit very low activity at the moment, but we still have it. It's still try to have meeting now and then. Happy to have some collaboration with the German Bitcoin Blockchain Association. If we see there is any benefit from that. I'm also the Scandinavian ambassador for the Bitcoin Association, or the BSV Association, as it's called now. So what we are doing with UNISOT is that we are assisting companies in their digital transformation journey, and we are helping them to connect their physical assets, so physical object like products like their clothing, phones, food articles, Norwegian salmon, and so on. And then we create what we call a smart digital twin in the blockchain. In the public blockchain. So this is very, very important for us. We are not using any private blockchain. Our whole idea and the whole, I'm super convinced that for this to work, we must use a public blockchain. That is not our blockchain. It's not a centralized blockchain by a couple of companies. It's the global public blockchain out there. And we are using that global public blockchain to facilitate global traceability and sustainability, and creating this, as I mentioned in a slide before, the global interoperability between all the companies in a supply chain. So we are empowering the digital transformation from Web 2 to Web 3. So I'm sure most of you already know what Web 2 and Web 3 is, but just for the people who don't. So Web 1 was the first initial web where everything was decentralized. Everyone was running their own web page and so on. So it was super decentralized. Then we came into Web 2, where we are now have Google and Facebook and Amazon Web Services, where we're actually centralizing everything back in again to centralized companies. What we do now with blockchain and the digital transformation is that we go from that centralized model back again to the Web 3, where we are decentralizing things again, thanks to blockchain technology, creating global interoperability and data monetization. This is a key thing as well. A lot of companies talks about blockchain, but they don't have token. I see now they're trying to implement tokens, but the tokenization is a very, very important thing here, where we can start monetizing information, putting price on a small piece of information. We do this by using, as I said, the public blockchain, IPv6, the new Internet version protocol 6, and AI technologies or machine learning technologies. There's a very, very interesting connection between the blockchain protocol and the IPv6 protocol that I will talk more about later on. So what we are then doing is that we're helping companies, providing a platform where they can prove their products to the customers and consumers, so that they can prove sustainability, that they can prove the provenance of the products, where they're coming from, how they've been treated, and so on. Prove the quality of these products, are they up to the specifications? Prove every single ingredient or spare part in a product, and trace every single spare part or ingredients. Handle the environmental impact, the environmental reporting from all of this, and also handle the ethical sourcing. Like I know you have now in Germany the supply chain traceability law. I can't say it in German, but I know there is a specific German name for that. We also have it now in Norway since more than a year, the supply chain traceability law here as well, Åpenhetsloven here in Norway. And this is coming to all countries in Europe that must have that to prove that there is no child labor or slave labor and ethical sourcing of products and so on. And as I mentioned, the way we do it is linking the physical object to a digital object in what we then call a smart digital twin. And example here is wine, for example. Every wine bottle could have a unique QR code, which is connecting that bottle up to the blockchain, to the digital twin. And by that, we can get the traceability. By using technology like RFIDs, QR codes, nanodots, crypto anchor, there is a lot of new technology coming up now as alternative to RFIDs, where you can put a very, very small identifier on a product, on a spare part or something. There are these nanodots, for example. It's like a small drop of epoxy with some diamond dust and some magnetic dust. And when that epoxy hardens, this diamond comes in a specific configuration, so you can actually get a unique identity that is small, like 1.1 millimeter, and you can put it on any kind of product, more or less, and it is impossible to change or try to move it. If you try to take it off, it just breaks up in 1,000 pieces, so you can't move it around. On the picture here, you see cap tag, which is specifically for bottles, and RFID specifically for bottles, because there are specific problems with RFID. You can't just put any kind of RFID on a bottle with with a fluid inside, because that will impact the antennas of that RFID. So there are some specific patents and specific companies doing these in specific ways. There are others. We are working with CapTax. There's other companies doing this as well. And what we get out of this is then the digital product passport. So we are collecting information from the whole supply chain, as I will show a little bit about later on. But when you then scan a consumer or anyone in the supply chain, actually, this can be used for quality control as well. When you scan this QR code or RFID, you get up, first of all, a branding page. That's nothing new. You have a lot of product in the supermarket today with a QR code, which goes to a normal fixed website, nothing strange. But of course, we have that functionality. But what we are adding by using the blockchain is this provable data and the live data, which means that by scanning this, you can now get provable live data about the content of this product, the origin of this product, how much energy has been used, and so on, the chain of custody, proof of quality, proof of origin, and all these kind of things. On top of that, we are adding functionality for feedback. So quality feedback or feedback from a customer. So you can input here, or you can give it a rating. This is not a normal rating like you rate a restaurant or hotel or something. It's not meant to be a public rating. It's meant to be a communication channel, to set up a communication channel between the consumer and the producer, so that the producer can now get direct feedback from the consumers, so that the producer can now start fine-tuning and maximize the quality or output of their productions because they have feedback. And that's a big lack today, to actually get up-to-date real feedback from the end customer of your products. So that's one of the functions that we have. Another functions that we have is, we call it loyalty certificates. So if a customer really loves this product and they want to support this company or this producer, they can now donate an amount here, like 5 or 10 euros. And for that, they get a loyalty certificate, kind of token back to their phone, which they now can show to friends and family and say, oh, look, I'm supporting this company. Or a good cause that company is working on, like with UNICEF or Save the Children or something like that. But the interesting thing here that you can track and trace that the money that you are donating, you can trace it back and see that it actually went to the workers, or it actually went to Save the Children, or whatever they want to send it to. The way we do this, so now we come into the more technical part of this. So we provide this universal source of truth by providing global interoperability and data monetization. So that's the two key functionality that we are providing. And we do that by connecting all the actors in a global supply chain. So I'm going to show you a supply chain here now for wine, for example. So you're planting a wine tree. What that company is doing when they're planting this, they create a smart digital twin in the blockchain. To this digital twin, they can now add information about the quality, the type, how much energy they're using, how much water they're using, where they're planting it, the quality of the earth, and all important information to prove the quality of this plant or any kind of raw material. This could be oil, or this could be iron, or any other ingredients from raw material. When they create that, they created a smart digital twin. And then when that plant, or next step in the supply chain, in this case here, they're growing grapes on this one. Now they can transfer this digital twin to the company who's growing these grapes, if it's not the same company. And now the next company in the supply chain, they now have proof of the quality of the raw material. And now they can continue add information about how much water they're using, how much fertilizer they're using, how they're treating this product, and what they're doing with it. and adding more and more information to this digital twin. And so we continue in each step. So you have harvesting, you're adding that information to the digital twin. And then we can add functionality because we have a document management system or with electronic signing that you can create a product certificate or harvest certificate here and get it digitally signed by an auditor or any kind of controlling instance. Then we come to processing. So in the processing, you get the twin, you add information in this twin about how you're processing it, where you're processing it, if you're mixing different spare parts or different ingredients together. So I mentioned here that what we are adding to this digital twin is also relations. So a smart digital twin can have a number of parent twins, which is all the ingredients of a product. So we can now, we are actually building up a DAG network or DAG tree of all these digital twins. So you have all the input information, and then you have the product itself, which is a digital twin. And now we can follow that digital twin through the supply chain like we're showing here. We can add product certificates that is signed by an auditor. We can go out in distribution. So we actually launched this system back in 2020 and started in the seafood industry. So that's why we mentioned seafood chain here, which is one of our platform, our branding of this platform. So what we did there was to trace everything from the egg production to the breeding of the fish to the transport and to the slaughtering and all the way out to a sushi restaurant. And we added IoT sensors to, no, I can't show that now, a small label with a temperature logger that we put on the fish boxes. So you can register locations and temperature and all different important information about the transport of that product. That could also lead to customs documents, so we can digitally handle and sign bill of ladings and customs documents and stuff like that. Coming out to retail, adding information how they are treating and how much energy they're using in the freezer, in the retail store or something like that. And then coming out to the consumer. And this is now where maybe the most obvious cases for the digital product passport. The digital product passport can be used anywhere in the supply chain, but this is the most common way to see it. A consumer is now scanning the QR code, as I showed before with the wine bottle, for example. We are now taking all of this information and aggregating all of these digital twins and present that data as provable information in the digital product passport. So that's the whole key functionality to the system. And that's, of course, very interesting to use also for recycling. So we know what kind of packaging material it is. We know the ingredients of the product and so on, so that we can reuse it and recycle it and so on. So this creates what we call the 360 global interoperability and traceability between all the supply chain actors in a global supply chain. And of course, since we're using the public blockchain, we also have payments, nano payments, we call it here, because we can do very, very, very small payments down to a thousandth of a cent. That also means that we can monetize information. We can put a price on a small piece of information, like one temperature or one location. We can put a price on that down to like hundreds of a cent. And now by that, we are now creating an information marketplace so that any actor in the supply chain here, they can now get new revenue streams by starting selling their data. For example, a farmer, they have a lot of information about the weather, how much it's raining, the quality of the soil and so on. That could be interesting for other companies in the supply chain. It could also be interesting for company outside of the supply chain, like an insurance company or investors or something like that want to bet on the harvest that is coming later on. So now we enable a small farmer to start selling their information, or any other company. It could be the distribution company like you have track and trace today. Most track and trace today don't work very well because the company are not making a lot of money on it. But we could actually start giving them new revenues, giving the transport company new revenue stream by having live track and trace information that company is paying for, that they're paying for every single data point that they get. So you could subscribe to, I want to, if this product is very important for me, like the temperature of this product is very important for me, I could subscribe to get an update every hour or every day or every minute or whatever you like. And then I'm paying a couple of cents for each data point. So that's how we create a new marketplace for data exchange. And that's what I've seen missing in my work as an SAP integration architect, that there is a lot of standards. You have a lot of EDI standards and a lot of other standards, data standards. But the problem is that we are still exchanging those data with manual, with email or WhatsApp, or you're building specific point-to-point interface and try to exchange this. So what has been missing a long time is this global data layer, the universal source of truth. So that's what we are providing. But that's not enough just to have a data layer where we can exchange information. You also need the economic incentive to exchange information, because from scratch, companies do not want to share their data. They don't just want to give away their data because it has a value. It has, data is the new gold. So by enabling companies to put a price on their information and give them the functionality to be able to buy and sell information between each other, we create this economic incentive as well. So that's the two really key functionality that I think is needed in supply chain to make supply chain more sustainable and more efficient than they are today. There are some papers that I've studied and come to the conclusion that global supply chains today, they have an efficiency from raw material to consumer, they have an aggregated efficiency that is less than 20%. So 80% is waste in our global supply chains today. And that's crazy. That's why the global economy is stagnating, but because our global supply chain are so inefficient. And that was actually Japan was the most efficient at 20%. The second most efficient was Germany, of course, on 17.5%, I think. But the rest of the world has less efficiency than 17.5% on global supply chain, which means we have so much waste of energy and money and efficiency that it's crazy. So by using a global public blockchain, and if we can just help global supply chain to be a couple of more percent efficient, like instead of 20, maybe 25, that would mean gigantic that have a gigantic effect on the global economy, on global sustainability, and all of these things, which is super important to get now. So yeah, that was my rant about that. So let's go next to the next picture here. So we want to help company to do this as easy and cost efficient as possible. So I mentioned I started building my vending machine, so with a small module in SAP. We still have that module, so we call that an SAP plugin. So our model is that we are going to build plugins for a lot of different other ERP systems and all different kind of systems, so that it's going to be it is very easy for a company to connect to the blockchain. We give them the plugin, and with the plugin, they are now connected to the blockchain. So instead of doing like I have been doing for the last 20 years, where I was building point-to-point interfaces between companies, now they just need one integration to the blockchain, and now they can be connected to everybody else via the blockchain. So we can minimize the number of interfaces, because that's a big problem today with all these interfaces. They are expensive to keep alive. They're expensive to keep up to date. There are a lot of security problems if you don't keep them up to date and maintained and so on. And and very costly to do. We can replace that with one plugin, one interface up to the blockchain, and now you're connected to everybody else. And it's not just that they are connected to everybody else. That actually also means that every company can now become a blockchain oracle. That every company can now publish their information on the blockchain as an oracle. And a very easy example is distribution, logistics. So a distribution company, when they are delivering a package, they can now put out in their blockchain oracle on the blockchain that this package has been delivered at this place at this time. Now other companies in the supply chain can use that information with their smart contracts. So now they can activate all this, any kind of business process. So do the payment, change ownership, or anything that has to be happening because of that delivery. And you can see it's not just delivery, that could be anything. When something happened, when the harvest is, when something happened in the factory, when something happened in retail, when the consumer is doing anything, all of that can now be automated together. So we have intercompany integration, intercompany processes that we can do with smart contracts in the blockchain. And this can of course be used as well, not only for traceability and making supply chain more efficient. We can also use it for sustainability reporting, like scope 3 or life cycle assessment or ESG and all of these kind of. So just like we are collecting information about temperatures or location and things like that, we can just collect information about how much energy, how much kilometers, how much waste, and so on. So we are working on a functionality here with the eLiability Institute, where we are actually calculating these just like accounting. So more or less in the same way that you have VAT today, you have value tax on every step in the supply chain. We have greenhouse gas emission added at every step. So by having source information from ERP systems, from accounting systems, transport systems, and so on, we can now have very specific information, not like today, because most of these reports today are based on assumptions that if you're running a truck from here to there, it's 150 kilometers and it's 50 tons, then it's about this much CO2. But you have no really idea if that truck actually run the 150 kilometers, or it was a traffic jam somewhere, or derouting, so it was 160 kilometers. So that information is not really collected today, meaning that our ESG reporting, our life cycle assessment reports and scope 3 reports are very inefficient or very unexact. But by using eLiability accounting and collecting specific information from every step in the supply chain, we can now produce very, very accurate and exact reports, like the EPD, life cycle assessment, scope 3, and so on, in these digital product passports that we have. I think this is a very interesting in these times now when we have the ESG reporting and all this mandatory reporting coming up. Then I want to talk a little bit about the technology and why we're using the blockchain that we are using, because there is a lot of discussions about private blockchain, public blockchains, and different kind of blockchains. In my view, there only exists a public blockchain. That's the most secure, that's the most cost efficient that any company can use. And it's also important that the blockchain can store data. And the blockchain that we are using can store unlimited amount of data. We can store gigabyte of data in every transactions. But of course, we still have the GDPR and we have data security, data integrity rules, and so on. So the basic functionality is that we store data on chain, but some data is not allowed to be stored on chain, like private information and so on. So we allow every company, every customer to decide how much data they want to store on chain, because we can store unlimited data, and how much data they want to store on a local distributed database, and then just secure that in the blockchain with a hash. So, sorry. So we provide both the blockchain, the global public access to the global public blockchain, and we provide access to a distributed database. So company can decide how much data they put on chain, how much data put off chain. Sometimes you can put big videos and pictures and big data sets. Maybe because it's still more expensive today to put that in the blockchain. We see, if we extrapolate how the public blockchain works today, we see that in maybe 5 or maybe 10 years, it will be more cost efficient to put data on chain. It will cost less to put it on chain than it costs to put it on Amazon Web Services today. But of course, today it's still more expensive to put it on chain. So that's why we have this functionality, so customers can decide. If it's very big data sets, it's still rather expensive to put it on the blockchain. Then they can put it in the local distributed database, and then just secure it on the blockchain with a hash. We have different technology to do that, so it's not just a simple hash, but we are also doing something called triple entry accounting that maybe we can talk about more another time. But triple entry accounting and auditing is a very interesting thing as well, to lower auditing costs for company up to maybe 80-90% lowering the cost. But we can mention that later on. We are also implementing AI into this, or actually federated learning. And I think that's a very, very interesting topic to combine blockchain and AI and IPv6. That creates a very, very interesting, I call it, that's what I call is the Web3. Because what we can do with combining blockchain and AI or federated learning here is that we can keep or increase the data privacy. There is a big problem today with AI that you have to copy tons of data, terabytes of data from your local system up to a central AI. And then all the processing is done in the central AI. But we already seen a lot of example of this, for example, in ChatGPT, that I think it was Samsung or different companies are uploading sensitive data to ChatGPT. And now that data is out there, it's lost. So the privacy is lost for that data. So and that's a problem we have with the centralized AI today, that company has to copy a lot of data. It takes bandwidth, costs, and they're losing control of the data when they're copying out to a central AI. What we can do with federated learning is a very interesting thing, that companies are not copying their data. They're actually doing their local analytics locally on their own data, and they're only sending the learning from that data. So the weights, the AI weights, the learning model, that's what they share, which is much smaller data sets. So we have less bandwidth. You keep the data privacy and the secure data integrity. And what they do is that they can share now just the learning of their data. So that's very interesting here in a global supply chain, for example, that each company in the supply chain, they keep their data, they do analytics on their data, but with a general or with a combined algorithm. And when everybody have made their own learning from their own data, they can now upload the learning from that data, and we can aggregate that. And we can send back the learning from everybody's data back out to each actor. So that means that each actor now kept the data privacy. They learned from the whole supply chain, like they can do forecasting, they can do maintenance planning and all of that with data from everybody without actually knowing the specific data points, but they know the learning from every other actor in the supply chain. So I think this is very interesting because that can also lower the energy consumption for a centralized AI because we are distributing that out both over time and distance. So we can hopefully lower by combining what people often complain about, high energy consumption blockchain with a high energy consumption AI. By combining two negative now, we can actually lower the consumption of everything here, which I think is very important. And what we also can do is that we can now incentivize each actor in the supply chain economically by paying the one with the best learning results or best learning model, or you can monetize the learning models and start a marketplace for learning models as well. So there is a lot of very, very interesting thing to do here. And how IPv6 comes into this is that with IPv6, we can do secure device-to-device communication by actually monetizing each data package on IP level, on the lowest internet protocol level, and encrypt information between device to device. I'm going to talk more about that later on here, but that's a very, very interesting thing to combine blockchain, federated learning, and IPv6 together. We don't have any ready solutions for this yet. We're working on it and still developing it, but it's a very, very interesting use case. And then to make it as easy as possible, I mentioned ERP plugins. We have a whole integration platform, so we can talk to IoT devices with different protocol like MQTT, Modbus, and so on. Of course, we have a whole range of APIs that we are selling our system as a software as a service or as a platform as a service. So as a platform as a service, a company gets access to all the APIs. We have SDKs, and of course we can do custom built integrations as well. So we want to do it as easy and cost efficient as possible to integrate all the systems in a global supply chain to the blockchain. And this is close to my heart because of my background to do these integrations, but we want to do it as efficient and secure and cost efficient as possible. Another function now with the supply chain due diligence, the supply chain due diligence law that we have got, we have built a solution there, so we can automate the due diligence of your suppliers. So if you have a producer and they have a number of suppliers, I just take 3 here as an example, the top 3 suppliers. So we can now automate the due diligence mapping by going to this system, find out the top 3 suppliers, send out a message to these 3 suppliers that they now have to answer a couple of questions about child labor, slave labor, and so on. And then they have to give their top 3 suppliers. And automatically emails are sent out to them. They have to fill in about their slave labor, child labor, and so on, and then give their top 3 suppliers. So we are automating all of this to do the whole supply chain mapping downstreams. And we are collaborating with a lawyer company, an auditing company. So because there could be a lot of secret information here that a lot of suppliers don't want to give out the information about who their suppliers are. But so this is all kept secret and is handled by an auditing company or any other third party that could be independent. So when there comes information that some company down in the supply chain could have child labor or could have slave labor or have some indicators that here we have to do a more specific investigation, Then that information comes up in the dashboard, and the auditing company can now go out and do an audit on that specific company. This dashboard can also connect or make normal PDF reports, or connect to other due diligence mapping systems that or due diligence systems that company have. So that's one function. We can also use our system for circular economy. We know that every step in a supply chain have input, have output, the product, and we have waste. And by a function that's called mass balance reconciliation, when we do that on every step in the supply chain, we can now very easily detect if one producer is adding water to a product without, or adding anything to the product without actually registering it, or if they are not registering their waste. That means that the mass balance reconciliation calculation will deviate from zero. It should be zero through the whole supply chain. All input should equal all output. But if there is extra input or less output, the mass balance reconciliation will not be zero, will be plus or minus, and then will be directly indicate that, oh, here is something not reported that came in or went out from the product. And this can also be used for circular economy. We can manage reuse of products, we can manage recycling of products, and we can go the whole ecological loop of products. So this whole system creates very detailed traceability. So we had an employee who made beer. So down in the bottom here you see a beer bottle. On the top you see all the ingredients of a beer. So what we could do here is that we could trace if one product is bad, we know exactly how that has been used, how that has been processed and transport and everything all the way out to the product. So this means we could do very specific and very exact recall of products. We can also go the other way around, where you scan a QR code on the product, as I mentioned, from a wine bottle, for example, and now you can go the whole three upwards here and see every process, every ingredients, and everything about that product. Talking about then shortly about IPv6 as a last point, how by combining IPv6, I'm not going to go through the whole list here, but we can share the presentation afterwards. But what we can do with the IPv6 and blockchain together is that we can get very secure device-to-device communication. So you have two systems here. You have an IT system. You have, for example, an IoT systems, temperature sensors out in a room. What IPv6 and blockchain can do now is that we can have a secure identity of each device. With this secure identity, we can create a secure encrypted communication channel, device to device, between these devices. And then, for example, we can send out a signal to all the devices that I want a temperature in this room for the last hour. Does any IoT device have this data? And then the devices can answer back, yes, I have this data, and here is the price. You have to pay 50 cents for it. Then the system can actually pay that 50 cents to the IoT system. And by paying that and get the receipt and get that registered, now they get the sensory data back. And all of this can be automated on the blockchain. So this creates a lot of very, very interesting scenarios where IoT devices can have their own economy, more or less. And we can be sure that we get correct data from correct device. So this is, I think this is super, super interesting. We have a lot of different products in our system here. So we have the seafood chain, as I mentioned before. We have fashion on chain. So we have customers in fashion industry. We just launched this year down in Dubai, halal on chain, to trace that halal is actually halal. We have wine on chain. We also have kosher on chain. Of course, halal on chain is on one side for the Muslims. it's the same functionality for kosher on chain. So I was in New York this year or last year, and if you just go to a hot dog stand in New York, for example, most of them are kosher. They say this is kosher. So it's not just for the Jews, but it's actually becoming a quality stamp for food, or not only food, but more or less anything, because they are tracing the whole supply chain, and we can now help them doing that even more efficient. Freight on chain, agri on chain, food and beverage on chain, and then we have the UNISOT API. So we are selling the API as a API service as well. And we have the sign on chain that we also launched last year, which is an like DocuSign, but secured on the blockchain. So it's a kind of document management system and an electronic signature system. Some of our customers, I'm not going to go through all of that, so I'm going to jump to questions and answers after this. We're also building everything. I will mention all our users get a DID, distributed ID in our system. So we have verifiable credentials and verifiable presentations and all these kind of things. So now we can jump over to questions. So I've been talking a long time here, so happy to take any questions.
Ja, Stephan, tack så mycket. Thank you very much for this very, very good presentation on this topic. Very interesting solutions you have. My first question is, how much of all these slides you've been shown is already in a product or ready to sell?
Most of it. The machine learning is still in development. Mm-hmm. The federated learning is not in production yet, but the rest is in production. So we have customer using it.
Okay, and the audience, are there questions? Fire away, please.
Yes. If I may, how can I access your solution? I assume once the participants in the supply chain have their connection through the plugins, can I, as a third party, also access this supply chain, or do I need to access this through your APIs?
It's a good question, and there is often a misunderstanding by using public blockchain that people think that everything is public. It's not.
Yeah.
It's just like we are using right now the public internet. It's a public internet system, but it's only us now in these video conferences that see this information because it's encrypted between us. It's the same thing with our system. Yes, we are using the public blockchain network, but all information is encrypted between party to party. So as a third party, you cannot see anything. You see some encrypted information in the transaction, in the blockchain transactions, but you have no idea if that's a temperature or location or weight or whatever it is. To get access to that information, you have to connect with that company that owns that information and ask for that information, and get the keys and get access to that information.
But it would be possible in principle that I create a service that I could sell to this company that is already using your service, but I can access this information from the supply chain on behalf of this company then.
Yes, that could be done. Yes. But of course, each company, each data owner, they own and control their data, so they have to give access to the data to you or to anyone that wants to have this data. Yes. So data integrity and data access is very, very securely kept.
Johannes, please.
Yes, thank you for the presentation. I have not fully understood, I think, with regards to just the previous point that was discussed. how this is like helpful, in what way it is helpful to even put like encrypted data on the blockchain. Like for me, that makes things more complicated. As you said, if someone wants to access this data, they have to get the keys. But now, once these keys are used, well, only these keys can be used. So now someone else comes, they get the same keys, etc. Like, and then maybe I want a different version of that same information. I'd have to post it on the blockchain again. Like, is it not much simpler to just, if I have to contact this other party anyway for the keys, to use, you know, peer-to-peer data exchange of verifiable data, like verifiable credentials, etc. Like, for me, it's never been clear in all these 10 years of traceability and blockchain why we need to put any data on the blockchain whatsoever. And then my second point would be interoperability. You mentioned that you achieve interoperability along the supply chain, but if I didn't miss it, it wasn't really explained how that was achieved. If everyone's using your system, yeah, it's interoperable. But how is that achieved if people use other services that already enable them to, for example, digitally sign data? You know, what kind of standards are at the bottom, at the foundation of your solution, basically?
Right. Yes. Yeah. Good question. That's the whole reason why we are using a public blockchain, because it's not our blockchain, and we are using industry standards. Industry standards for EDI, or for like GS1 for barcodes or QR codes, or ISO, all different other ISO standards too. So right now, as far as I know, we are the only one using this public blockchain and with these industry standards. But the idea is, of course, that this should be an open system with open standards, so that even if a customer are coming from us and are using us to put data on the blockchain, it should in the future be possible for another company, another supplier like us to access the same information. So we're trying to build some kind of open standards here, but
right. But would the other parties need to use the same blockchain then? Because even if it's a public blockchain, it's one out of many blockchains, right? So
yes,
but it seems unlikely to me that everyone would start using this blockchain.
Yeah, my view on that is that there will only be one global blockchain, just like we have one global internet. One global main blockchain, I should say. There will probably be a lot of small as well, but the blockchain is a time stamping ledger. It's a clock, and just like we have just one global time, that would just, in my view, that will just be one global blockchain that everybody is using. So that's a view I'm coming from. That that there is one global blockchain.
Yeah,
which can of course talk to other blockchains and do atomic swap and so on if that's needed. But there is no other blockchain out there today that can compete on that, let's say, 5 different characteristics that we are looking for in an enterprise blockchain. It has to be super scalable. It has to do a number of, let's say, 1 million transactions per second. We are almost there. We are doing at least a couple of 100,000 transactions per second, but are coming out a new Terra node now, which will do 1 million transactions per second. It has to be, so scalability, super important. Stability. This is the only blockchain, as far as I know, that has a locked protocol. That there is not a number of developers that are putting new functions into the core protocol every now and then. That's key to have a secure enterprise system. I mean, if a company creates a token or a smart contract today, they have to be sure that that smart contract works tomorrow and works in 30 years. No other blockchain has that except this one with the locked protocol. We know that if we create a contract today, it will work in 50 or 100 years. It also has to be very cost efficient and energy efficient. And as I mentioned here, transaction cost in this system here is down to like 1/1000 of a cent. So and we have economy of scale which means that the more we are using the system, the cheaper it gets, the more energy efficient it gets. Like most other blockchains today, the more you're using it, the more expensive fees you have, and more expensive it is, and more energy it takes. This goes the other way around. And thanks to the stable protocol, it's also legal. It's not automatically a security if you create a token here. It's more like a raw material, because you don't have any central group controlling the protocol or controlling the blockchain. As soon as you have a group of developers controlling the protocol of the blockchain, then that blockchain becomes a security, or the tokens in that blockchain becomes a security. So and as far as I've seen, there is no other blockchain that has that.
Okay, and which blockchain is that?
We are using the original Bitcoin protocol from Satoshi Nakamoto from 2009, not to be confused with BTC that everybody thinks is Bitcoin today. So we are using the blockchain that is called BSV, Bitcoin Satoshi Vision today.
And then maybe one more, sorry. Why do we need to write like actual supply chain, any data, even if encrypted on the blockchain? How does it make, what does it achieve without adding a complexity?
So what we achieve very, very easily and very cost efficiently, we achieve data integrity and data availability, that you can trust the data that are in that blockchain.
Yes, but
because nobody can change it.
Can't I have both much more easily without using a blockchain?
The question, yeah, but how?
With digital signatures, I verify credentials. I can put a timestamp in the verified credential.
Yes, but
I can make them available.
Will be in a centralized system that someone owns and controls.
Yeah,
yeah. That's one of the key things, that nobody owns and controls this blockchain. It's a global system out there.
But you said the data owners should own and control their data anyway.
Yeah,
so
yeah.
If that's the case, then we don't need the blockchain.
Yeah. But they should control it. They are controlling the data, absolutely. But it's on a public system that nobody else can manipulate or do something.
Okay. Thank you.
And also, it becomes very, very cost efficient, because this system is out there. It's running by itself. It has its own economic incentive. We call them data processors, but it's often called miners. Each miner, they don't care what the system is used for. They're just running their mining operations and making money on that, on making the system more secure over time. The more they want more and more transaction to make more money and making the system more secure. So there is a healthy competing algorithm there with the proof of work system.
Okay, hold on a second, Basilios. Further question here. Stephan, so there is no EVM compatibility or IPFS system compatibility at the moment?
No. EVM,
not planned.
Mostly both of them, because they are not scaling, because they are not secure.
But you could write a plugin for IPFS.
Yes, we could. But again, it's IPFS is not scaling for an enterprise environment. It's not. You don't have the data integrity, and it doesn't scale, and that's the two main problems with IPFS. Mm-hmm. It's super interesting technology. It's super interesting solutions, but using it for an enterprise.
So if we have several stakeholders in the environment, the Web3 community, they are already using ARC tokens or different other blockchains in the supply chain. So is it a do or die if they want to integrate your system?
It's very interesting now. You mentioned ERC20 tokens that are used in many EVM systems. We now have the BTC20 or BSV20 token. So we are now doing compatible tokens in blockchain, Bitcoin blockchain systems. There is a couple of blockchains based on the Bitcoin protocol and the proof of work that now can use that technology. If it's die or do not, I mean, we can still integrate to this other system, but it will be an integration. Yes, we can do that. So we can exchange information with EVM systems.
Mm-hmm.
But it would be like a normal integration to any other system, so ERP system or production system, or just to exchange information.
Mm-hmm. Vasilios, please.
Yes, thank you for the presentation. My question is related to the micropayments that you mentioned for data monetization. I assume these are on-chain, but if that's the case, isn't the transaction cost high? And this is a fundamental problem for any decentralized public consensus base. So please elaborate a bit on this transaction cost of micropayments. Thank you.
Absolutely, yes. Good, very good question. Yes, and that's a big problem on specifically EVM blockchains, because they're super expensive. If there are not a second or third or fourth layer on top of that, but then you have already lost the data integrity forever. The transaction costs in this blockchain to do nano transaction, the transaction cost is, as I mentioned, thousandths of a cent. So we can make transactions down to a thousandth of a cent, which is a really nano transaction. We can sell a location or a temperature for thousandths of a cent, which there you are. And the more we use the system, the cheaper it will get. And that's contrary to every EVM system or every other blockchain, more or less, because we have the proof of work algorithm. That is what is driving all of this. Actually, Satoshi Nakamoto, he solved the problem of proof of stake in 2009. There was already cryptocurrencies using proof of stake in the 90s. But Satoshi, he solved that problem because proof of stake centralizes and de-incentivizing miners to be more secure. You only incentivize to stake more and more and more, to hurdle more and more coins to get more power. That's what Satoshi solved with proof of stake. You're not hoarding tokens. What you're doing is actually the more cost efficient you can mine and the more secure your security you can provide, the more money you make, which means that the more money you make, the more secure system gets. So you have this positive loop that when you use proof of work, the system gets more and more efficient, more and more secure over time. A proof of stake system goes the other way around. It gets less and less secure because nobody cares about the security of the network. Nobody's incentivized to invest in hardware to make the system the network more secure. They're only incentivized to have more tokens to have more power. Proof of work is the opposite of that, and that's what's so funny, because everybody's talking about this, that, oh, we have to go over to proof of stake to be more efficient, to take less energy and so on. It's just bullshit, because you're not measuring the energy in the same way, and you get a less secure system. So yeah, it's funny.
Okay, thank you.
Thank you, Stephan. Are there any other questions? Okay, Stephan.
I'm sure that make a lot of enemies by saying like this, but I've been investigating blockchains since, as I said, 2014. I started with BTC at the time because there was more or less the only one available. Then Ethereum came. I looked into that, of course, very interesting with smart contracts and tokens and all of that. But that was a big misunderstanding that Bitcoin could not do tokens or smart contract. Actually, it can. And as we are doing now, our smart digital twins are NFT tokens, of course. And it has been proven that Bitcoin is Turing complete in at least 4 different ways. And that was the whole reason why Vitalik started Ethereum, because he thought a misunderstanding. He thought that Bitcoin was not Turing complete, that you could not do tokens and smart contracts, but we can. Very cost efficient, very secure as well. Sorry, yes.
Yeah, you're welcome. I think we're well open-minded here, and no one is here from the XRP army or a Bitcoin maximalist or whatsoever. I have a question for you, but first of all, Emmanuel, please.
Hi, thank you for your presentation. Very interesting. Me too. I'm a Bitcoin maximalist in the cryptocurrency area, and I studied it from 2014. Me too. So we are on the same boat.
Yeah.
But what I'm wondering is two aspects. I have two questions. The first one is your blockchain is, if I understood correctly, is a Bitcoin blockchain equivalent based on.
It is the blockchain since 2009. Yes, the Bitcoin blockchain.
You use directly.
Yep.
The Bitcoin
Yes.
blockchain. Okay.
Yes.
But storing data on that blockchain,
yeah,
I think is a bit difficult and expensive, because we have there are limits on the block size, and there are.
That's the thing, that we are not using the BTC that you probably are thinking about. BTC is a hijacked copy where they limit the block size to 1 megabyte.
Exactly. So you have another blockchain.
No, we have the original blockchain from Satoshi Nakamoto from 2009 without the limit of block size. So we regularly have block sizes up to like 3-4 gigabyte.
Okay, you use the same protocol, not the same blockchain.
Yes, the same blockchain, the original blockchain from 2009. Yes.
Yes, okay. You use the original.
But there has been a copy. So BTC actually copied that whole blockchain.
Okay. You made a fork. What is a fork of that blockchain?
No, it was not a fork. It was actually a legal. It was actually a legal copy.
Okay, legal copy. Okay, if you want to see a legal copy, but your nodes operate with a different protocol, with a modified protocol that accept block size unlimited.
It's not a modified block protocol. It's an original blockchain protocol from Satoshi 2009. The one he published in 2009. That's the protocol we are using.
Okay, but it's not the protocol used now for Bitcoin.
No. For BTC, for the BTC, that's a modified, because they in 2014 they added SegWit, or they introduced SegWit. They took away the signature, so they just screwed up the protocol already there, and then they added and removed a lot of functions and things. So the BTC is a super modified, not or original Bitcoin protocol anymore. But that's a very common misunderstanding that most people think that
you're using the original one.
Yes.
Anyway, what I don't understand is that how many nodes are working now on your blockchain with the original protocol that you.
Yeah. I don't know the exact number, but there is a lot of
mining. How many nodes are mining? How they monetize? Because you need a cryptocurrency to monetize if you use that protocol.
Absolutely, yeah. We have the Bitcoin, we have the Satoshis. So I don't know the exact number of miners, but there is also a big misunderstanding that, like Ethereum or other blockchains, that they have thousands of miners. That's not correct. You have a handful, 5, 10, maybe 15 actual mining nodes that are creating blocks. You have a lot of people that are connected to a mining pool, But these people that are running an ASIC rig, they are not actually they are not actually the node creating the block. The mining pool is creating the block. So what we see today is a handful, 4 or 5 big mining pools that they are the actual nodes that are creating blocks in the blockchain. And that's the same for Ethereum, same for BTC, same for all the blockchains out, the public blockchains out there today. They are a handful of nodes, not more.
Okay. Anyway, I ask you the second question. So, what do you think about the EBSI, the European blockchain infrastructure, and because you are UNISOT is in Trace4U consortium. So
yes.
How do you think to be how do you think to integrate your projects, your business, and your blockchain based on the Bitcoin Satoshi Nakamoto original blockchain with the EBSI?
So this is a very good example on how we can integrate with another blockchain. So what we are one of the goal of the Trace4EU consortium or project is to have interoperability between different systems. So that's what we are going to prove here. We're going to connect our seafood chain, because our role in that project is to trace seafood. So we are going to connect our seafood chain based on BSV blockchain, and we are integrating that with the EPSI blockchain, or it's integrating with the EPSI blockchain via APIs, like everybody is doing. Nobody is really running the EPSI blockchain except countries. You have the different countries in EU. They are running a Hyperledger node, and then they're providing APIs to everybody that wants to use this blockchain. So we are using these APIs to integrate. So when we create a smart digital twin in Seafood Chain, we will also create a representation in the EPSI blockchain as well with an API. So that's a normal API integrations between these.
Stephan, I'm wondering about the minings and the storage. You said that storage is at the moment not that cost efficient, and that Amazon would be a smarter choice at the moment. I'm wondering, from my background, I'm thinking if I'm a miner, I have to storage everything, and the other miner has to double that to copy that. So it's a huge amount of data. And so how do you think that would be cost efficient in the future?
Yeah. That's a very interesting theme to talk about, because if you look at how data is stored today, just take that you and I we are in a supply chain, a small supply chain. I have my ERP system, you have your ERP system, which means that and in my ERP system, I store my data, and you store your data in your ERP system. So we already have 2 copies. But then I probably have at least 1 backup of my data, maybe 2 backups. So, I mean, I have the data 3 times in my system, and you have the data 3 times in your system. So we have 6 copies, at least, just between us 2. Now, if you take a supply chain with 5 actors or 10 actors, you have to multiply all of that data. Everybody have backups of all of their data. This is where the benefit of the blockchain comes in, that you can actually rely on data on the blockchain and just have for you 1 copy in the blockchain. That copy will be automatically distributed to a number of nodes, maybe, as I said, 5 or 10 different nodes. And if we scale this up, you can see the benefit that we're actually storing data less in the blockchain if we have a secure public blockchain instead of all our different system and all our backups and everything.
So you are saying that SAP and all the other stakeholders in the ERP world realm will go public with their data in a public blockchain?
There's two things there. They will not go public with the data. They will not publicize every data, but just like we are doing, they could use the public blockchain to store the data securely and encrypted. But that doesn't mean that everything is public for everybody. It's just
that's crystal clear.
Most SAP instances today is running on like Amazon Web Services or any cloud, which is like public cloud. But yeah, it's all encrypted in their own area. It's the same with the blockchain.
What do you think about governance?
Just a storage network. Sorry?
What do you think about governance? You know, every big company has its own governance. So is it compatible?
Yeah. That data governance will be the same thing. Like they're governing data in an Amazon storage today,
but instead of the company has a hand on the Amazon storage, but not on the public blockchain.
They have the same.
They have only the hash word. The hash.
They could have the same control of data if it's an Amazon container or if it's on a blockchain.
Okay.
Storage.
Emmanuel, please. Thank you, Stephan.
I have some doubt about your vision because I continue to have some doubt because this reason why the current Bitcoin BTC blockchain adopted many years ago a limit on the block size is due to the number of nodes that have to validate and replicate the blockchain. And in your vision, you need to have maybe some magnitude order more than that number of nodes that currently are working on for the BTC blockchain. So I don't think that is possible to have an unlimited block size in your in the vision that you are proposed. And this is the reason why EBSI, the European blockchain, is based on a permissioned logic, not permissionless like BTC. So and also there are some difficult to understand from my point of view how you can combine the permissionless blockchain with the limitation on data access that you described before. And only on this aspect, if you consider EBSI, European blockchain, you see how they solved these issues with a permissioned blockchain and with a limitation on data inside blockchain, on chain. Okay, so I think that your vision is very different from the vision of EBSI.
Absolutely, yes.
I cannot understand, also, I cannot understand how your vision can solve the issues that EBSI is solving, or the issue that BTC blockchain solved many years ago.
Yeah, but first of all, the reason for the block size was not the number of node or anything. The reason for the block size limit that they put into BTC was because they were afraid of spam. So it was just mentioned.
No, sorry. You cannot reach the consensus if you have a so big block size, because the block size.
Yes. That has nothing to do with the block size.
Require too many time to be elaborated and to be transferred.
No, that's not correct.
You introduce a big issue in the transfer of the block size.
No, No, that's not correct. The block size does not impact anything about the proof of work or the number of nodes. It's the same amount of work if it's a 1 megabyte block size or 10 gigabyte block size. It takes the same amount of work. That's the scalability. That's where the scalability comes in.
But you have to transfer that block size. If I transfer
yes.
gigabytes of block size, it's not like 1 megabyte.
No, right. But that's also not, it's not a problem to transfer terabytes of data. Just look at Google and Facebook or Amazon. They are transferring trillions of terabytes per hour. I mean,
yes, not if you are a public, a permissionless blockchain where everybody should have cannot have any company cannot have, if you want to have a node, cannot have the same bandwidth of Google or Amazon.
That's a good key. That's a very good key, because that's not the intention. Like Satoshi said from the beginning, it's not, and that's a big misunderstanding in the whole crypto and BTC world, that everybody should run a node. Our customer is not running a node. The nodes, they're run by big data centers around the world. And that will be, let's say, like a handful of big data centers around the world. These data centers, they have all this capacity. They can communicate with each other. They have point-to-point.
It's not a permissionless blockchain. It's
yes. With the permissionless.
It's becoming exactly a permissionless blockchain, because only if you have data center like Google and Amazon, you can run a node. So it's not anymore a permissioned.
Yes, it is. It is.
Like a
That's what it is. That's the invention of Bitcoin. It's a handful of data centers running this. It's not everybody out around in the basement and stuff like this. I'm very sorry, I have to run to another meeting, but this was super interesting. I'm happy to take more questions offline or at a later time. So,
yeah, thank you, Stephan, for having this interesting
insights. Thanks for very good questions. I love these questions.
Yeah, I will contact you at another time. And thank you for today, and see you soon. Bye.
All right. Thank you, everybody. Nice to talk to you. Good questions.